Hey team, let's start in on our first pillar concept for pathology. Remembering that pillar concepts are allowing you to kind of get this sense of, oh my gosh, there's so many different topics presented in this class, so much content. How do I kind of focus, and what's really important for me to get out of this particular section of the class? Pillar concepts help you focus. Okay, so first one is typical function of the immune system. In other words, understanding what the immune system is and how it works. That's where that content lives in your curriculum here in this class. Next are the concept of cascades, building between the inflammation response and the immune systems. This idea of how does that chemical signaling process occur, and understanding that gives you a real sense of where different things can come in terms of medical treatment. Next will be two simpler ideas, the idea of the immune system being overactive and the idea of the immune system being underactive. Let's kind of look at how these pillars are going to articulate across this content. Okay, first, typical function of the immune system. Okay, so to protect the body, you have a lot of different ways to do it. There's our physical and chemical barriers, there's something called our innate immunity, and something called our adaptive immunity. The idea of these pillar concept lectures is also kind of to give you a sense of acclimating to the different terminology we're going to be using, because if you haven't heard the phrase innate immunity, you might be like, whoa, what does that mean? Okay, so there's a lot of different processes, and they all get different names, right? Okay, so this is a slide you're going to see that discusses that. So your first line of defense are your physical and chemical barriers. So that's things like your actual skin, the pH of the layers of stuff that's on your skin, mucous membranes on any orifice in the body. That's your first line of defense, okay? Second line of defense is going to be something called your innate immunity, which covers your acute inflammation processes and allows the triggering of more processes as needed. Third is your adaptive immunity. This is specific and long-lasting. So honestly, when a lot of people think of the immune system, what they're actually thinking of is adaptive immunity. Oh, your white blood cells that encounter something bad and learn how to make antibodies to fight it the next time they see it. That's not wrong. It's just that's actually the third line of defense. That's your adaptive immunity. The thing that we call inflammation, people don't realize that's actually part of your larger immune system. We call it inflammation, but really the whole thing is, we call it that just because it's distinguishing who gets in there first. This is kind of a who plays first, who plays second, who plays third sort of thing. And so I think that's why it's easier to think of first line, second line, and third line of defense. Okay, so within this, as you're coming into the different types of protection your body uses, there are different cells that are active at different times and have different jobs. So I'm giving you an example of one, something called a natural killer cell. So what you want to have a focus on is what is the cell's job, what does it do, and does it call anything else? Does it make any other events happen? So for example, a natural killer cell, I know that name is so aggressive, right? It's basically constantly sniffing for something you're going to learn about called your MHC1 complex. This is a protein expressed on the surface of nearly all of your cells that basically says that you are you, the individual. So for me, all of my cells have a protein. My MHC1s are specific to Lizzie G. Lizzie G proteins are on the outside of all of my cells except red blood cells, because nobody has those. So the protein that's expressed there, so long as it's on the membrane of a cell, the natural killer cell is like, oh, that's fine. And so what it's always doing is it's got this little lock and key mechanism, and the little, you can see here on the left here, it's got this little thing that needs to fit. And if it doesn't fit, then it's like, oh, that's bad, I'm going to destroy it. And it does this all the time. It goes on default. Anything that doesn't have a correctly expressed U protein, an MHC1 complex on the outside, is automatically destroyed. So that's why I say it's always on, and it's in Cinderella mode. The shoe has to fit perfectly. If it doesn't fit, nope, destruction. Okay? So if it doesn't fit, then you get granules, okay? And so granules are fun because that can cause other things to happen. So that's kind of your sense. This thing is always on, and what's interesting is cancer cells have mutated proteins on the outside, and that's actually partially how your immune system destroys cancer. It's constantly doing that. Cancer happens basically accidentally all the time in the body through mutation, and your immune system is constantly destroying cancerous cells. So this gives you a sense of the role of a certain cell in the immune response, like its job, how it works, and if it calls anybody else. Okay, so this is a slide you're going to see. There's quite a few cells that you're going to learn. This gives you a sense of where they land in context. This is the normal function of the immune system. And so here's an example of that first line of defense here, giving you examples of the physical and chemical barriers and distinguishing them. So Oh, look, here's tears. That's actually a chemical barrier. Why? Because there's actually antimicrobial things, enzymes in tears that can, just by the nature of their biochemistry, disrupt the cell walls of certain types of bacteria. That's amazing, right? So you don't even have to like trigger anything else. This is just always there. You always have enzymes there. They don't have to think. They're just there. It's just chemistry. And yeah, you're good to go. Versus physical barriers, we have stuff like keratinocytes that make us generally waterproof, so it's hard for bugs to get in, right? So just giving you examples of how you're going to learn the different forces that protect the body as part of your understanding of the normal immune function. Next is Cascade. Ooh, okay, so this one we're going to draw because this is a pretty important concept. It gives us the idea of understanding what's going on in the body in the context of something going wrong at the very beginning, okay? And the inflammation cascade, as it can build into the triggering of the innate and adaptive immune responses, is this absolutely amazing coordinated orchestra of different cells calling different things so that eventually you can find what's going on, destroy it, and heal. That's basically what the immune system has to do. It has to find the thing, the bad thing happening, and recognize that it's a bad thing, destroy it, and then heal. That is honestly the function of the inflammation response and the immune response. The ways they go about it are really different, right? And there's a lot of other factors that come in, and you can see where things can go wrong, or where we can have medications come in, or we as PTs can have an influence, but we have to get in there and understand the process so that you can see your role in it, right? So that's what you're going to see here. So you have stuff like this. This is one of the early cells that comes in, and this is one thing we're going to be drawing during class. So then that inflammation, you can think of inflammation as the early response, and later you have the immune response. And so what you're going to understand is how one talks to the next one so that different waves of cellular defense kick in, okay? So like what actually is an antigen? We're going to talk about that. Now, of course, these systems can go awry. Basically, you can have all of these systems on for way too long. That's a problem too. Always remember that the immune system is a massively energetically expensive system to have turned on. Sure, it's always there, just kind of, destroying a random E. coli you accidentally ate from, some burger joint. But also, if it's actually turned on all the way in its full active mode, you're burning a lot of energy. Think about when you just have a cold and how tired you are, let alone if you have a more serious pathogen inside of you. In addition, nothing is free, truly. In some ways, the immune system is immensely elegant. In some ways, it's kind of barbaric. And so there are trade-offs. Basically, you accidentally hurt yourself while healing yourself. That is truly it. That is, in essence, what happens with inflammation and immune activity. So we call this leukocyte-induced tissue injury, and this is normal. It's actually normal. You get these bystander tissues that happen to be near an infection, and they get injured too. So we'll talk about that more because this can be a serious problem in a lot of different pathologies, as I'm sure you can imagine. What makes the immune system overactive? Well, we'll talk about different causes. So things like allergies, things like autoimmune disease, when we talk about specific pathologies related to immune function and dysfunction. We'll talk. So for example, here's one you're going to get to learn, hypersensitivity. So this is the one that you know of as kind of like allergies. And this is a good one to know, because when it becomes fully out of control, you can end up with a really scary situation called hypersensitivity anaphylaxis, anaphylactic shock. Okay, so this is it right here. This is you learning what it is, what it looks like, and why we're worried, okay? And you can see that this has the flag system on it. So you're going to learn some conditions that are more serious, and there can be things like, oh, okay, I really need to understand this because I need to be able to recognize it and be looking out for it in different time frames. I'd say that's one of the big things to know here. What is happening and how long has it been happening for? Really important, right? I've got things like acute onset and late onset. Then we've got other things like rheumatoid arthritis. This is a slide from your rheumatoid arthritis content. A powerful, powerful condition you're going to learn about, and you're going to see how immune dysfunction leads to joint erosion. And that's all of the different many beautiful systems malfunctioning, working when they shouldn't, in places they shouldn't for way too long, leading to rheumatoid arthritis. So basically what we're seeing here is just prolonged immune activity is really bad. Overactive immune responses can create a lot of tissue damage. So you can think about somebody who's had bronchitis for 6 months, right? So you can even have massive, more systemic high immune activity, which is scary, like an anaphylaxis. And we want to be thinking about all the different things that are going to happen. because, again, the energy expenditure is so high, the tissue damage can be so high, and you can actually end up with this weird situation where when the immune system has been active really high for so long, you actually almost like run out of cells. So you can end up with this like secondary immune suppression because you just don't have enough adaptive immune cells, and your body can't like keep up with the demand. So you kind of end up with a shortage. It's bizarre, but it kind of makes sense when you think about it. Like, oh right, all of these cells have a lifespan. If they're active for long enough, you don't have enough supply, like in storage. Underactive. Okay, so this has two situations. Either the immune system is weakened through damage, or it is shut down. So the causes are variable. You can have medication that's intentionally causing this. You can have a medical condition such as HIV, or you can have social determinants of health or lifestyle that are causing this as well. So what we want to think about with this is a particularly scary thing. We want to think about like, okay, what kind of complications can I anticipate? What do I need to watch out for in my patient? So for example, in an immune suppressed patient, you need to look out for pneumonia, right? Things like that. And what are their specific health needs? You're going to learn about something called reverse precautions, where because they have a suppressed immune system, you are the hazard to them because you have all kinds of bugs all over your skin crawling all the time, which is disgusting but true, and isn't a big deal for a healthy immune system, but for a suppressed immune system can be quite dangerous. So learning about, okay, how does the immune system get suppressed? Why are we medically depressing the immune system's function? Well, because it's overactive, so we need to suppress it. It's a trade-off. We manage their risk for catching a bug. In return, they don't have out-of-control rheumatoid arthritis, right? So it's a tough concept to wrap your head around because you're like, wait, we're intentionally turning off their immune system because their immune system is too active, which also means we're also making them susceptible to bugs. Yes. Yes is the answer. And that's a ooh, right? That's rough, but that is the nature of medicine at this point of time. Jump forward 100 years and maybe science will be different, but right now that is what we do. Medical conditions can cause this, such as HIV. So here's the most powerful one, right? Possibly one of the most powerful immune suppressive conditions out there is HIV. Why is it so dangerous? Because this particular virus infects your adaptive immune system as well as your macrophages, which you're going to learn about, are one of the biggest players across the entire immune system. And it has a unique etiology that makes it particularly dangerous. Okay, so next is going to be, we'll talk about this some, right? This is actually going to live in some of your other classes, such as health promotions and things like that. But things like social determinants of health, if somebody doesn't have good food intake, how are they supposed to have a healthy immune system, right? Or if they don't have a home and they don't have shelter, how are they supposed to have a good immune system? If they have chronic severe depression, how are they supposed to like try to manage themselves so that they don't get sick all the time? Things like that, right? So these are the sorts of things that we're going to talk about because immune suppression has many, many, many different effects. You have all these changed risks to different things and different responses. Yeah, I mean, one of the classic signs that somebody has certain forms of blood cancer is a wound that won't heal, right? So those are things we want to think about as we're learning about this pathology. Here's another example here. Oh, here's the one that this one always kind of messes with people's heads the first time they learn about it. There's an entire class of drugs that turn off your immune system in different ways. And the ways in which we do it, you're going to learn about. So it's the chemical signaling. So that's why you learn the cascade at all, right? That's why we have this slide right here, to give you a sense of why we're learning the cascade. Because different drugs turn off different pieces of the cascade to try and decrease immune activity. It's that simple. So I've given you a preview here of some of the slides you're going to see. You don't have to know specifically anything off of this pillar concept sequence here. It's to give you a sense of why we're learning everything, what it's for, and what you can expect as the priorities, right? So let me jump back here. So pillar concepts represent the most important things for this content. It's important for you to understand the typical function of the immune system, how it turns on, basically, which in this language we call a cascade, when it's working too hard, when it's not working enough. And so with that overactive and underactive, those are going to be specific conditions that you're going to learn about, right? Like lupus, rheumatoid arthritis, HIV, conditions like that, right? So that's what you can look forward to in this class's immune content. Thanks, team. See you in class.